Hello. Okay, we will continue in this class the remaining portion of this border plot, the procedure for construction border plot. So in the last previous two classes, we will cover that what is the border plot and what is the basic procedure and what are the factors will affect on its magnitude and frequency response. So today in this class, we will see the basic procedures for plotting the border plot. So let's see that. So what is the border plot? How many graphs here have to plot? Two plots, right? One is the magnitude plot, second one is the phase plot. So magnitude versus frequency, phase versus frequency. And photo plots are only approximation plots. We are not going to plot the exact plots. So approximation plots only. So in order to construct this magnitude plot, so for example, they are taking that one transfer function g of s equal into k into 1 plus st1 square divided by x square into 1 plus st2 1 plus st, right? What is the basic step? So first we need to convert S domain into J omega domain, that is in terms of frequency domain. And we need to observe that what are the product terms we are having in the given transfer function. That is either it is integral factor or derivative factor or first order factor or second order factor and so on like this. Next, once we will to convert this into the frequency domain, we are able to calculate the corner frequencies. So corner frequencies. What is important of the corner frequency? Already I said in the previous class. What is the corner frequency? Corner frequency is in a frequency. It will separate low frequency region and high frequency region. High frequency region. Under this low frequency region, in general, magnitude is 0 decibels, right? Okay. So how to calculate? How to calculate corner frequency from the given transfer function? That also we will discuss. So yes, we will take this standard equation 1 plus STT, 1 plus STT. So then 1 by T will be used at corner frequency. For example, here they are taking that omega C1 is 1 by T1, omega C2 is 1 by T2, omega C3 is the 1 by T3. And they are assuming this T2 less than T3 less than T1. So then the corresponding frequencies is in the inverse. So that's why corner frequencies are omega C1 less than, omega C3 less than, omega C. So so this is the basic procedure. First, we need to convert the given transfer function to the frequency domain, and then we need to calculate the corner frequencies. Okay, why we need to convert the corner frequencies? Because based on the corner frequencies only, we have to estimate that magnitude. For example, one frequency is 5, one frequency is 10, one frequency is 15. Then what it means that so previous class already said that magnitude plot consisting in terms of logarithmics, just adding all product terms together. For example, 5 means if I take the graph, initially until the value of 5, magnitude is 0 decibels and then followed by some other. And if I take that 10 frequency, magnitude is 0 until this 10 and then followed by either plus 20 or minus 20 depending on the factor. And 15, so magnitude is 0 decibels until this 15 and then plus 20 or minus 20 depending on the factor. So if I know these corner frequencies, then only I can arrange that order in the terms in the order. Otherwise, if initially if I write the first 10 product term and then 5 product term, then its magnitude values will be different. So that's why we need to arrange all the product terms based on its corner frequency values. Okay, that's why first we need to calculate the corner frequencies. So then if you're observing that, uh, how to construct the magnitude plot? How to construct magnitude plot? So first we need to convert the transfer function to the Bode form. or else time constant form. It is also called as a time constant form. Time constant form. So then we will get this in this notation. So then second one is, so we need to create one table. That table will consisting of these terms. What are that? The first column will have the term. That means what are the product terms we are having. That product terms we have to list in this table. And then corner frequencies. Product term, the corresponding corner frequency. Product term, the corresponding corner frequency. And then slope. We have already some basic idea. If it is integral factor, what is the slope? Minus 20 decibels per decade. If it is a derivative factor, what is the slope? Plus 20 decibels per decade. If it is the first order in the denominator, what is the slope? It is also a minus 20 decibels per decade. Initially 0 decibels. After that, what is the change? Slope minus 20. Like that. So we need to arrange all the product terms in the first column with respect to the corner frequencies values in the increasing order. Okay. And then change in the slope. So what is the change in slope means? Okay, we will see in the next step. And already I said that any magnitude plot will be depends only first initially the three terms, either constant term or integral term or derivative term. So I can skip this constant. I can take mostly, of course, there is some problems are there. Only they are having the only constant also, like 5 by 1 plus 4s into 1 plus 5s like that. But majority of the problems we are having that either integral or derivative. So rarely we are having that constant factor also. So we need to assume that. So that means the first term is always either constant term or integral term or derivative term only. Why? Because the magnitude response initially depends on these terms. Why we are not taking the first order or second order means, since the only the one reason is first order factors or second order factors, initially the magnitude is 0 decibels. After that only either it is minus 20 or either it is a plus 20. So that means initially at the lower frequency regions, the magnitudes will be depends on only the following parameters, any one of the parameter. What are the parameters? Either it is an integral factor or derivative factor or constant factor. So here I have one question for you. What is the meaning? What is the question is? What is the corner frequency value for the either constant factor or integral factor or derivative factor? Is there any corner frequency? What is the meaning of corner frequency? It will separate the low frequency region and high frequency region. That is, the initial slope is 0 decibels at the low frequency region, and then slope will be decayed or rising either plus 20 or minus 20 or plus 40 or minus 40. Right? But what about the integral or derivative or constant? From the initial frequency omega 0 to infinity, you are having the same slope, either minus 20 or plus 20. That means there is no corner frequency for the integral term or derivative term or constant terms. Okay, please remember that. Either it is an integral or derivative, 1 by s, or constant terms, there is no corner frequency. Okay, and then next, we have to list the remaining product terms based on the corner frequency values in the increasing. I hope it's clear. So, and then, for example, if you are getting the values are 1, 5, 10. Okay, omega C1 is 5. Omega C2 is 5. No, sorry, omega C1 is 1, omega C2 is 5, omega C3 is 10. Okay, then we need to take one lower corner frequency, omega L. Omega L value. How we can choose this omega L? Omega L will be known as the lowest corner frequency. Lowest corner frequency. So how we can take this omega L means basically this omega L value should be less than the first corner frequency. Omega L value should be less than first corner frequency. For example, you are having the value of 1 is the first corner frequency. We need to take the smaller value for that one. For example, I can take that 0.1. Lowest corner frequency is 0.1. Is it necessary to take 0.1? No need. We can take 0.5 also, 0.8 also, but what's the condition? It should be less than the omega C1. So omega L value should be less than omega C1. In this condition, you need to follow. So then, for the first factor, uh, omega at omega L frequency as well as at omega C1 frequency, we are going to calculate the magnitude directly from the given product term. Okay. So how to calculate? So 20 log of something. It is a, for example, integral factor I am having that. So then I can take this 20, 20 log of 1 by j omega. Let us take 1 by omega. So this for this value, I can take the magnitude at omega L directly by substituting this and omega C1 directly by substituting this. Okay. So again, I will refer in the problems. So don't worry. We will see in the problems also. And once we will complete the magnitude value for the omega L and omega C1, from omega C2 onwards, so we are not going to calculate the frequency magnitude directly. So we can use this formula. So what is the formula? So change in the gain from omega x to omega y. That is omega C1 to omega C2. How much change in the slope and what is the previous gain value simply. So no need to calculate. Directly we will substitute the values. What are the values? Previous gain value and present change in the slope. Next one. At omega C3. Again the same formula. Omega C4. Same formula. Omega C5. Same formula. So until we can take this, how many corner frequencies we are having. So for those corner frequencies, we need to calculate in this criteria one. The magnitude should be getting in this criteria. And the next last one, last but one, we can take one omega h. What is omega h means? It is a highest corner frequency. Initially, what you are taking lowest corner frequency. What is the condition for the lowest corner frequency? Omega L. Omega L should be less than omega C1, first corner frequency. What the condition for the highest corner frequency means? Omega h value, this omega h value should be greater than highest corner frequency, omega C3. For example, if I am having the three corner frequencies, then this omega h value should be greater than the omega C2. Then, for example, previously what you are assuming 1, 5, and 10. So then this omega h value should be greater than 10. You can take any value 20, 30, 40, 50, 100 also. That's all this. So based on the problems, we are going to assuming that omega h value and omega c1 value, omega l value. Okay. Is it clear? So once again, so at the first lower corner frequency, so we need to find corner frequencies and then we need to arrange this. We need to arrange this in a table. So the table, the first term must always that either integral term or derivative term, and there is no corner frequency for that integral and derivative term. And then we write the slope, and the remaining factors will be placed according to that corner frequency values in the increasing order. Once you can complete this table, then we are going to take the two frequencies, that is lowest corner frequency and the highest corner frequency. Lowest corner frequency value should be less than the first corner frequency, and the highest corner frequency value should be greater than the highest corner frequency omega h should be greater than the omega C3 or omega C4. In the given problem, what is the value we get? For that, we should take the highest value. And how to calculate the magnitude? So the magnitude should be calculated directly from the given term, either given integral term or derivative term, depending on the function. Integral term or derivative term at omega L and omega C1 with the help of the term. Next, from the second corner frequency on to the highest corner frequency, we are going to follow this form. So what is the change in the gain from previous corner frequency to the present corner frequency and what is the gain at the previous value? Okay, how we are getting this change in gain means, so this is the formula. So what the slope from omega x to omega y into log of omega y by omega x. Okay. And finally, we will take one semi-log graph and this semi-log graph sheet. So we need to find out the frequencies according to that problem. and we will draw this magnitude with respect to the frequencies on the x-axis and magnitude on the y-axis. Okay, sorry. Magnitude on y-axis. Okay, here I'm writing A. A indicates that magnitude. Magnitude on the y-axis in terms of decibels. And frequencies on the x-axis. We will take this. So then we need to connect all the points by a smooth curve. So we cannot draw with the help of freehand. So you can use the scale. So, and then we need to represent what is the slope change on from one point to one point. So we need to write the slope change on the magnitude. Okay. So then the magnitude plot will be, and then frequency plot. So for the same, already we will calculate the phase angle phi function. So again for that value, so we can create one table. So what is the frequency and what is the corresponding phase. So like that we need to calculate. Okay, we will see one problem in the next class. I hope it's clear the procedure for constructing the magnitude plot and polar phase plot. Okay, thank you.